Can people hear me? Okay, so hopefully the first part of this live stream came through. If you're just starting to hear things now, I'm just talking about the first outcome. Did you just start to hear me? Okay, I'm going to quickly recap. I'm not sure. I just had to click another setting, so I think the video just started coming through. So just recapping, I'm just going through the first unit, going through the 12 questions, which is the limit, or around 12 is what you're going to have on thermochemistry. There's 2 general outcomes, and of the 2 general outcomes, I'd be putting most of my questions from the first general outcome. So my apologies if some have heard this already. So the 8 or 9 questions, the first one that would be part of a question, not a full question, would be the fact that hydrocarbons get their energy from the sun. Students have told me they see that pretty much every year. Make sure you do select the sun in that question. I've heard it's been around so much that it's never going to be a question on its own. So 1.1, probably not a question. I'll talk about that down below in a second. 1.2 will be half a question. Outcome 1.3K, define enthalpy and molar enthalpy. There's no defining or words. I've not seen the diploma, so I just got a comment in the chat. What I'm doing is guessing what I would put on the diploma to help people study. So I haven't seen the diploma, I don't write it. I have done item writing once, and anything I've done in item writing I couldn't talk about. So there's no secrets other than, there's no secrets coming other than what I would put on a diploma exam to help students study and focus. So it's just my experience on what I would make, and I've been doing this for 15 years. So I wouldn't skip this outcome on the diploma. So what this 1.3 outcome might look like is what I've underlined in yellow. Students often they think this question is too easy. You get an equation, you get told the enthalpy change is negative or exothermic 250 kilojoules, and then they ask you what the molar enthalpy of maybe D is. And it's as simple as taking the energy term and dividing by 4, because there's 4 Ds. So sometimes a question that's overthought. So that would be my first full question. Outcome 1.4 and 1.5, write balanced equations for chemical reactions, including energy changes, and use and interpret delta H notation to communicate and calculate energy changes. I would be writing several questions on that outcome. And this is where the communicating enthalpy lessons that students should have learned would tie in. You should be able to jump from a chemical potential energy diagram to a equation with delta H, which is what we have here. You should be able to take the enthalpy change and write it as a term. So it would be a product term. You go plus 250 if you wanted to write it as a term, or you could turn it into molar enthalpy. So, we're up to maybe 2, 3, 4 questions in total up to outcome 1.5. 1.6, students need to learn to use the 2 pages in their data booklet of enthalpies of formation to predict the delta H for a reaction. So I certainly, if I was writing a diploma, would put that as one question. You're not going to see that over and over again. There's just so many outcomes, and you're just not going to see repetition. So it's not worth crazy studying one skill. spending an hour on this before the diploma. It would only be one. Same as Hess's Law. On a unit test, when I write it, I tell my students Hess's Law will be there once, and if I was writing a diploma, I would put it there once, and students tell me they see it pretty much on every diploma. Again, there's about 15 years of me teaching and seeing diplomas and getting feedback from students. Use calorimetry data to determine enthalpy change. There's no way anybody would write a test or diploma without covering that outcome, and this should tie into labs that you have done. With my students, we both do solution-based labs. You mix an acid and a base and measure the temperature change, as well as burning something, ethanol, methanol. You could burn a potato chip, a peanut. So I would definitely include that, and as a student, I'd be expecting, you're going to get a calorimetry data question, and it's probably going to be in a lab format. A comment right from the bulletin. Everybody can see the Chemistry 30 bulletin. It's put out every year. They warn students to include the container. So if you're burning something and there's water inside an aluminum can, you do have to include the aluminum can if you have the data. And another thing in the bulletin that would tie in down here is Alberta Ed has said students are really good with calorimetry when it's water, but they're not always good to switch when the surroundings isn't water. So Alberta Ed is giving a hint to students that this is a problem. They're warning them. It may not be in every diploma, but you could have a reaction where the heat goes into a block of aluminum, and the C value for aluminum is right in your data booklet. So make sure you're good, and on, I believe it's page 3, you've got aluminum in your data booklet, iron, copper, water's there, and a couple others. Now there's only 12 total questions. If I was writing the diploma, these last two, I would just pick, I would now write one question. So identify liquid water and carbon dioxide are carbon dioxide are reactants of photosynthesis, and you need to be able to compare photosynthesis to cellular respiration and know that in any open reaction you get water vapor, and any closed system, something metabolic like cellular respiration, you get water liquid. You have the value for water liquid and water gas right in your data table, so you can make predictions, identify which one's more exothermic or how endothermic the reaction is with those values. So from this first general outcome for thermochemical changes, I would write 8 or 9 questions if I was writing the diploma. That's probably, the assumption in this video is that the people writing the diploma wouldn't be that much different than me. And I'm trying to guide or help your studying. So make sure communicating enthalpy is solid. Expect a fair bit from those. These are generally the harder outcomes in thermochemical changes. The second outcome more connects to chemical potential energy diagrams. Of these 4 outcomes, I would allocate 3 questions of the 12. So define activation energy. You're never going to be asked to define things, or I wouldn't expect it. It's not something students tend to see. They tend to need a label. Maybe there's a number on a graph. So the activation energy barrier is there. If my axis was numbered, you could determine the actual value. If this was labeled with a number 1, you could identify it. So that's one thing you could be asked. Maybe I would ask. One thing I personally love asking my students is understanding that the going up connects to bond breaking and requires energy or potential energy, and the going down, which I've labeled in green and then underlined in green, is bond forming, and that's always exothermic. So that's what's going on with this outcome. Bond breaking up, bond forming down. Chem 30 will always keep it simple with one simple pathway. IB and AP make it more complicated. If you're taking any of those courses, you don't have to worry about the complications you've seen in those. Now this is a potential energy diagram. Myself as a teacher and Alberta Ed wants to make sure you realize energy is always being conserved, so whatever potential does the kinetic energy sort of total does the opposite. So that's the second topic to be aware of for a possible question. Last 2.4, I would definitely include something about a catalyst. So the dotted pathway is the effect of a catalyst. The activation arrow that I put in has gotten smaller. It always will be smaller with a catalyst. It wouldn't be called a catalyst if the barrier got bigger when you added something. But the enthalpy change, which I'm going to circle in black, doesn't change when you add a catalyst. So I'd probably write a question from that and then something else from those two. So for thermochem, big focus on general outcome 1, particularly the calculations and flipping between the multiple ways of communicating enthalpy, graphic, equation, connecting it to a real life example. Real life being, what if you burn 4 grams of methane? You could write an equation, predict the delta H, and then you could solve for that 4 grams of methane, whatever the question gave you. So keeping going, I want to try to not make this video or tutorial super long. So I'm not going to have a lot of actual examples. A lot of things you're going to get. The helpful comments will be sort of oral comments, not visuals. Electrochem, 18 questions. A lot more outcomes. We'll take a look at what I would ask if I was writing it for general outcome 1. The first 2 outcomes are heavy and kind of show up throughout the exam, but it's definitely something I would put several questions specific to. Oxidation, reduction. I'm not going to do a define. It's going to be give an equation and you have to identify what's being oxidized, what's being reduced, and what's the oxidizing agent, reducing agent, identifying oxidation numbers, and I would certainly include something about disproportionation. So from this outcome, there's 18 questions now from this unit, so I would ask several from this, and I would make sure you're super solid with these 2 outcomes. If you're really good with these, you can make some good guesses down below with, balancing complex half reactions and, just being able to identify, that the question has to have the loss of electrons and knowing what side it's on knowing these outcomes can help you down there. Differentiate between redox reactions and other reactions. I would write that as one question. I go through all those Science 10 reactions with my students, and double replacement reactions are not redox. Single replacement are always redox. Formation, decomp, combustion are always redox. Now, I think Alberta Ed knows that teachers tell their students this, so they'll give reactions sometimes, or students have seen them, that they look double replacement, 2 things become 2 things. So don't go too quick, but it's really useful knowing single, replacement, formation, decomp, combustion, they're all redox. Next, we got identify electron transfer, oxidizing agents, reducing agents, and redox reactions that occur in everyday life. Not my favorite outcome. I do 1 question on it. In my class, I really focus on corrosion, so that's what I would like to talk about, but who knows what natural process the Alberta Ed would want to write a question on. Maybe they'd pick something more biological, the cellular respiration or photosynthesis side. Compare relative strengths of oxidizing agents and reducing agents. That would fall under the table building. You get a list of data. If there was a spontaneous reaction, you can put the oxidizing agent above the reducing agent in building a table. If you're given data that a reaction was non-spontaneous, then you would flip the RA above the OA. So hopefully you've done those practice questions. This is an outcome that I would certainly put on an exam, and this tends to be a standard of excellence type question, or that's what I would do. Predict spontaneity of redox reactions. I would probably just give you 4 equations and and ask you which one is spontaneous, or make 3 of them spontaneous and 1 not, or 3 of them not spontaneous and 1. So you're using your data booklet with this question and identifying things. Particularly watch for those ions that show up on both sides. So something like iron 2+ can be an OA and an RA. That can make this question a bit trickier. And then there's balancing complex reactions, either full reactions or half. There's a lot of skills here. These tend to be something that students might struggle with more, and I would probably write 2 questions from this whole outcome, maybe just 1, but possibly 2. There's somewhere you're going to get something of labeling oxidation numbers. I kind of wrote it down here, but it maybe fits more up above. I always, on a test, give you maybe 4 compounds, CO2, what's the oxidation state of carbon? Methane, CH4, what's the oxidation state of the carbon? And it's a nice numeric response type question. Last, I always put it in my exams, a redox titration. Students tend not to always rock this. Hopefully you remember your Chem 20 titrations. There's no fundamentally different skills between acid-base titrations and redox. You need an equation and a stoichiometry. So I would definitely review your titration skills. I would include it. So I would put about 9 questions from general outcome 1, so about half of the 18 questions. And then you're going to see this outcome, you need to know these first 2, B1 for cells, because your cell questions, which are coming up next, you're going to really struggle if you're not rock solid with OAs and RAs. So again, we have sort of a heavy outcome. Define anode, cathode, anion, cation, and all the parts of a cell. Now we've got a standard voltaic cell in 2 pieces. Now you could have a porous cup, and that's where the boundary layer. So porous cup is when you can take one of the half cells, put it inside the other. The example here that I took from an old diploma has a salt bridge connecting the 2. So definitely know all those pieces, and I would expect several questions on these terms. I would write several questions, and I do when I write exams. Identify similarities and differences between voltaic cells. We sometimes give lab exams to our students and put this outcome on a lab exam. I would certainly put 1 question. I wouldn't put more than 1. So hopefully you're familiar with the difference in both pieces and whether they're spontaneous and things like that. The lack of a salt bridge in an electrolytic cell. So a couple questions from the first one, one more from outcome B 2.2. Predict and write half reactions that occur at the electrodes. That's something that I'd write several questions on, but I might sort of mix a question that is half this outcome and that half that outcome. And you're going to see that a lot, or I would do that a lot in electrochem. Recognize that not all reactions occur as per the data table. This is one of the things I find the Alberta curriculum very nitpicky. I taught in Ontario. Something like this is not in electrochem there. But you've got to watch out for this question. I always put something on my test. I pretty much always used chlorine, the chloride anomaly, and you won't be told that it's coming. So watch out for the chloride anomaly. I would make it a question. Students have told me it doesn't show up in every diploma, but there's a reasonable chance, and I would most likely include it, but it is one of the things I would drop if I was running out of space, if there's only 18 questions. Explain that the value of standard reduction potentials are relative to 0. So the hydrogen half reaction in the middle of your table was just picked as a 0. You need to be able to switch that reference. So what if gold was picked as the 0? It's one of the half reactions near the top of your table. You should be able to re-zero any half reaction And this is something I would include if I was writing the diploma on every diploma, and that'd probably be a standalone question. I wouldn't be mixing this with the other cell questions. Calculate the standard cell potential for electrochemical cells. That's going to show up in multiple questions, but again, it might be mixed in as sort of a part A, part B to one question. Getting to then predict the spontaneity or non-spontaneity of redox reactions based on cell potential. Something, I would write one question from that. Hopefully this would be a more straightforward question. Connected to cell, voltaic or spontaneous, electrolytic or not. And then last, sort of all of my tests will have Faraday's law. It'll be a numeric response. Students often struggle with Faraday's law because they only need a half reaction. And often I or the diploma might give you an equation that gives a full reaction. Maybe something like aluminum is in a full reaction. And you don't have to, and you can just go to your table and find the aluminum half. Aluminum 3+ plus 3 electrons makes elemental aluminum. So you have to memorize some equations. Moles of electrons is I times T over F. I would definitely study that and be expecting one. I would not leave this one out. And again, that's sort of a nice standalone, isn't going to connect to anything. You can study this and focus right in on this outcome. So I do another 9 from the cell, so an even mix from the two. This is a little hard going through this list because it's just so broad that you've got 18 questions. You can't sort of leave anything out. You've really got to do a nice broad-based studying. You've got titrations, you've got cell stoic. In some of the other units I think be slightly more helpful. So we're through 50% of the exam, thermo and electrochem. Organic, so we've got general outcome 1 and then 2, which is more of the reaction part. So let's sort of see how I would dish out my 12 questions if I was writing the diploma. So define organic compounds and identify whether the carbon-containing things are organic or not. This is just a straight memorize. I would include it. Maybe I'd make it a half of a question. I'd probably make it standalone. I might make it a numeric response. You just have to memorize these ionic forms or oxide forms of carbon that are not organic. And then you've got a whole huge section of naming. And I've got videos on organic naming. Take a look at those. But I would write 4 or 5 questions from all those naming rules that you got. Generally, students find this fairly find the naming part fairly easy, and we'll talk about the reactions shortly. So hopefully at this point you're focusing on the reactions and you're good with the naming and drawing. Now you won't have to draw anything, but just go from a drawing to the name or boiling points or something from the drawing. Outcome C1.4, identify types of compounds, identify functional groups. So I would probably include this as a couple questions, but they would be parts. So maybe you have to name something, name an alcohol, and identify its functional group as a hydroxyl group. So expect this a few times, but again, probably parts of questions. You need to be able to deal with structural isomers. It's unfortunate that you won't be able to draw anything. So the typical format in multiple choice is just ask how many isomers something has. You need to be really systematic with this and make sure you don't miss one, because if you miss one, and A is 4, B is 5, C is 6, and D is 7, and you miss one, you'll just be wrong. You get no marks, even though you're one off. So go through your isomers. You need to be able to deal with melting points and boiling points. No, they need to have some sort of trend or link, and that's where the homologous series comes in. Maybe you're looking at enes, and the only difference is they're all enes, and they're going by 1 carbon. You should be able to do melting points and boiling points. from those series, or something with a nice controlled variable. I would put a couple questions on this. It's a little debatable whether there be one or two, but I'd be sort of in between. I'd consider more than one, so I would make sure this is something you study after you're good with your reaction types and your naming. I think every diploma I've ever had a student write, they've told me that fractional distillation was on it, so I would study that pretty strongly, and with that history record of what I've been told from students, that's where I would focus, and I'd write a fractional distillation question. I teach solvent extraction, but I've not been told by anyone that they have seen that, or at least not very often. The second outcome connects to the reactions. So it's a small list, but it's something that you're going to get a fair number of questions from. So I wrote 3 questions is what I would allocate just as 2.1, knowing your addition reactions, substitution, elimination, esterification, and combustion. Hopefully you've put these in categories. Addition reactions have to have a double or triple bond, that additional bond between carbons. So that your enes and your ynes, you got substitution of your anes and UV light. May or may not come up, that you'd be tested on knowing that there's UV light, but it's something you should know. You've got elimination, there's 2 types, alcohols and organic halides can both do eliminations and sort of go back to enes. You got esterification and combustion reactions. So anyway, I would allocate 3 and probably 1 as a numeric response. Here's 4 reactions, and identify, which one's addition, which one's substitution, which one's elimination, which one's esterification. Then we get on to the polymer ones. I don't enjoy teaching these outcomes because there's so much buried into this one. For years, my students said they just saw addition, polymerization, but you do have to watch out for condensation also. I'd expect 1 question from here, but again, there's so much to study. Make sure you're really good with everything in organic, and then if you're good, you could spend a bit of time on your monomers, polymers, the condensation and addition, and then some of the natural polymers. So that's where I'd allocate 4 questions here, and then I've used up 8 there. To oversimplify this, I kind of tell students for my unit test, expect 40% to be dealing with naming compounds, another 40-ish%, maybe a little less with reaction types, and then the last 20% with all the other little topics. And it's still a decent general guide going into the diploma, the 40, 40, 20. It's should be more like 35, 35, 30. But you've got the naming, drawing as one big category, and reaction types as the second. Last, we have equilibrium. That should say 18, not 12, so it's another one of the bigger units. I just mistyped that. We've got 2 big outcomes. Most teachers are probably going to start with, or I start with, Le Chatelier's principle, which is the 3rd outcome, and I would ask many questions, even with only 18 on the diploma. It's a super important topic, and this is where you can really tie in a lot of lab-based questions. You can be talking about shifts and ask, you do something, you add a stress, what would that stress do to the pH? Or what would that stress do to the color of the solution? On the back page of your data booklet, you've got the colors of a lot of ions. So, tin 2+, iron 2+, iron 3+, permanganate, and many others are there. So if you have a question on Le Chatelier's principle and you're asked, does it turn red or does it turn green? You have no idea where these colors are coming from. Go to the back of your data booklet and look for ions in that equation. Flipping back to the start, define equilibrium and state the criteria. That maybe is one question, but something that could be skipped. If anything, tying in equilibrium to the rate of the forward equal to the rate of the reverse is the one thing I would tie in. The notion of dynamic equilibrium, when you're at equilibrium, you're making and destroying the products at the same rate. So that can easily be made into a multiple choice. That's what I would do with that. Identify, write, and interpret chemical reactions for systems at equilibrium. It's a little hard. There isn't the word calculate showing up here, so I'm not always sure which outcome they're doing all the calculate type questions. But I'll address that, and I'm sort of labeling it or connecting the calculate down here in the define KC and predict. I would put a couple questions that are related to KC calculations, and I would put two sort of math heavy questions, and I would sort of make two more theory based questions around equilibrium constants. One topic being, what causes KC to change and what doesn't. So only temperature causes equilibrium constants to change. You dump in a chemical, you change the volume, you change the pressure, it doesn't affect the equilibrium constant. So that's sort of the type of theory I'm referring about. So I'm going to 4 questions are sort of coming from here, but here-ish, they're pulling in a bit of other outcomes. You need to be able to write, we're sort of into Bronsted-Lowry. You're not going to be asked to sort of describe what it means, but you'll be able to identify it. So this 0.5 and 0.6 outcome can sort of be mixed together. You need to be able to write Bronsted-Lowry equations. I once had a student tell me that they used an indicator. So make sure you realize all the indicators in your data booklet are just weak acid, weak base combos. The KAs for all those indicators are also right in your booklet, but largely you'll be using your acid base table to guide you in the data in the question to write equations. Definitely read carefully with my students on tests. They read too quick, and I might ask, what's a Bronsted-Lowry pair, or what are the Bronsted-Lowry acids? And students just get so used to writing pairs, they don't read the question. So if you get an equation, read carefully and make sure whether it wants an acid-base pair, or whether it wants, the 2 Bronsted-Lowry acids or the 2 Bronsted-Lowry bases. Identify conjugate pairs and amphiprotic species. Because there's so many questions from equilibrium, I would write a couple related to those outcomes, one of them probably around amphiprotic species, and that's a pretty important topic. So something like HCO3 minus is both an acid and a base. So that would be a question, and the conjugate pairs I could tie into a second question. The buffer question is easy for students to miss. I'd put probably just one question on a buffer, but the question won't necessarily tell you it's a buffer. So a question might just say you've got HF, hydrofluoric acid, and sodium fluoride, and the student would have to realize, okay, well, there's a weak acid, there's a weak base, we got a weak pairing, and that's going to resist the changes to pH. Versus if you had sodium chloride and hydrochloric acid, that's not a weak pairing, and that wouldn't resist or maintain a constant pH. So if you get a question about, is the pH going to go up, down, stay the same, is it going to be held constant, try to think, buffers is the hint, or the topic I'd be focusing on, or where I'd be going with that question if I'm not sure. Do I have a buffer? So I would get to 14 questions. There'd be a lot of mixing of outcomes in this unit. Several on KC calculations, several on Le Chatelier's principle. That's going to make up a good 50% of the questions. And then you've got these other topics like buffers, amphiprotic to mix in. So I've used up most of my questions for equilibrium. That just leaves 4 more for general outcome 2. So these outcomes are the more mathematical base. You've got recall, pH. Now it says recall because you should have learned this in Chem 20. Hence the recall term, pH, hydronium, POH, hydroxide. You've got all these harder new outcomes, and often there is a simple question on the diploma. I would certainly put one in that's just hydronium to hydroxide or Ka to Kb, and students sometimes overthink them. I teach AP classes, and these AP students often will just totally overthink a hard question and want to do a whole ice table and think of Ka, Kb, and it's just hydronium to hydroxide. So I do one question on something simple, one question related to Ka, either using it or calculating it, and one question on Kb, which is probably, here's a weak base, do an ice table, figure out the Kb, and then you could turn it to POH to pH. So through all of this, I'd probably make 4 questions. So sort of one there, one there, one there, and then I'd probably duplicate maybe a second one related to Ka, same topic, but not identical. And that's the 4 questions combined with the 14. Now you do have a bit of overlap. The skills for the KC questions and the skills for the KA, KB it's the same, write an ice table, solve the ice table, same strategies. So you've got a lot of questions on that fundamental math. So you'd want to make sure you're solid with those. There are shortcuts for solving the Ka and Kb questions, and there's a video in my Equilibrium playlist called Shortcut. As a teacher, you can solve these in about 10 seconds with your calculator because all the ice tables come out to the same patterns. You don't have to worry about the quadratic formula in solving anything, so they become fairly cookie cutter. So that's it for what I would do or how I would write a diploma if I was writing one, which outcomes I would focus on, which outcomes I'd have repeated questions, and there were a few outcomes that I would kind of have to ignore, mostly going back to thermo, where you only have 12 questions and you've got more than 12 outcomes. There's a question in the chat about posting this, and I will post it afterwards. So hopefully you've studied, and this can help tweak your final bit of studying. If anybody had a question, I'd answer a few questions, and then I will end the live stream. So I don't see any questions coming in, so I'll end the live stream, take a look at it, and then post it. Thanks for watching. Sorry, what would a combined unit question look like? I assume you mean combined within one unit. So a lot of questions will combine skills. I'll flip to redox. So you might have questions about an electrolytic cell, but and there's an outcome about the electrolytic cell is tied in, but then you also have to do the E0 cell, which is a different outcome. So that's how you sort of have mixed outcomes in the same question. Now, you could have mixed units, or certainly data that goes from one unit to the next. You could have organic compounds, and you're asked, what family is it in, or something about a functional group, and then you could be asked about the oxidation number of an organic compound. Yeah, so the diploma does not clearly separate different units, so there is the possibility they tend to put the questions grouped together. but you're not going to have like a line that separates organic and redox. You certainly could have overlap. Again, like I mentioned, something about the organic nature of methane, and then something about the oxidation state of methane. So you're rolling into the electrochemistry. All combustion reactions are, redox. You could be dealing with something there. Sites of good practice questions. Quest A plus, if you just Google Chem 30, released exams, unfortunately there's very few. So if you do a diploma prep from anybody, they're all pulling from the same exams. Quest A plus has all of those old exams, or they're also released in document format. Unfortunately, Alberta Ed has not released a lot of questions in the last 12 years, so there's not a lot out there. Yeah, other than, it's really just Quest A plus. All the other sources are just stealing Quest or borrowing Quest A plus, Quest A plus as examples. So just be some teacher's website that has questions. And sorry, I don't know of another good spot or teacher who's made questions. We tend to be pretty secretive when we write questions to save them for tests. So there's a question in the chat on the acid-base table. Is it that as you go up on the left, the bases get stronger? The bases are on the right in the acid-base table. The acids are on the left, the bases are on the right. The very top of the acid column on the left is the strongest. They're tied at the top. And then on the base column, it's the opposite. The very bottom of the right-hand column is the strongest. You get stronger bases towards the bottom, and the only strong base is hydroxide. So there are multiple strong acids. There's a whole bunch above the hydronium gray line. So top on the right, top on the left, bottom on the right are your strongs. With no other new chat question. So new question, when writing equilibrium expressions, so Kc equals, can the states be all pure solids or liquids? So we're going to drop solvents, pure things, from writing equilibrium law expressions. Now the diploma doesn't get too technical on this. Solids and water are the main things you would drop from KC questions. That's not a comprehensive list. For an AP exam, I would give a more complicated answer. We don't include things in equilibrium law expressions that have concentrations that don't change. So the amount of solids sitting on the bottom has no effect on the equilibrium. And if you're running a reaction in a huge pile of water, so you've got a liter of water and then you make or use up a little bit of water, it has no effect on the equilibrium, so we drop it. So solids and pure liquids like water, when there's some aqueous chemical, the two things to watch out for. I wouldn't expect anything more complicated. So question, is there questions that you have to use an ICE table? You never have to use an ICE table. It's a tool. I make all my Chem 20s and 30s do everything in ICE tables. I don't take marks off if they don't. So do you have to use the ICE table format? No, but will you have ICE table format type questions? Yeah, I would put in several. I forgot how many I put in. I think it was probably about 4 is what I put into my 2 questions of straight up KC, and I'd probably have 2 acid-base questions that you should use an ICE table. Again, if you get the right answer, if another layout, or you don't actually do ICE, if you get the right answer, you're going to get full marks. Well, I think I'm going to call it a night. Thanks for coming to my first test of a live stream. Hopefully things went okay. And again, thanks for joining me. And like anybody on YouTube, I really appreciate when people subscribe. I'm trying to get to that 1,000 in total. So if you're not subscribed, that is appreciated. I'm hoping in the future maybe to do some more live streams, and we'll consider doing some Q&As. I may or may not do an open Q&A session tomorrow evening. So question, how does the general approximation rule for acids and bases? So the approximation rule you have to use all the time, because if you don't use it, you have to use a quadratic formula. The heart of the approximation rule is that when the equilibrium constant is really small, the change is really small. So if you started with 0.5 mole per liter of a weak acid and the equilibrium constant is really small, you're going to end up with pretty much just slightly under that 0.5 mole per liter. So the assumption is assuming that if you start with 0.5 moles per liter, you finish with 0.5, you don't bother with the subtract x, and you drop that from your ice table. And then that simplifies the mathematics. And it's right in the bulletin. I'm not giving any secret. I haven't seen the diploma, but you are not expected to solve questions that have complicated math or require the quadratic formula. If you're an advanced placement student, that can be on that AP exam, but not on the diploma. So in theory, you should learn when to use the assumption, but the nature of the diploma means for all the acids and bases, you always use the assumption. The I value for the weak acid and weak base is the end or equilibrium value. Now you cannot use this assumption for all the KC questions. If the equilibrium constant was 2.5, you can't use this assumption. But all the weak acid, weak bases will have KCs below 10 to the minus 3. There's 1 or 2 in your table that the Ka is not that small, and you couldn't be asked that on the diploma. Again, it's in the bulletin, public information to all teachers and students that they do not expect you to use the quadratic formula on the diploma. So I definitely have videos in the equilibrium folder, including a shortcut video that might be worth taking a look at. So on the YouTube channel, equilibrium playlist, and look for shortcut, and that will go through setting up the an ice table and using the assumption and shortcutting it. So I appreciate the thanks, and thank you for showing up, and yeah, time to call it an evening, and good luck with your studying. And haven't decided yet, but there may or may not be a Q&A session at 10 o'clock tomorrow. I'll see how my time's going.